expression, not an equation. I can't just dive in and square both sides. I can't just say square top and bottom.
No, I mean in your use of.
Oh, my apologies. Good point. I talked last time in class about rationalizing substitutions, and here I didn't do what I suggested last time in class. Last time I squared both sides to make the differentiation process easier. The reason why I didn't do it this time is because I already saw at a glance that this derivative was sitting in the Lagrange position, so why bother? Just because it was easier. And if you had squared both sides, you're going to get the same answer in the end. You just got a little bit more cleaning up with your algebraic first. So everybody, what's next?
Maybe integration by parts?
You know, I'm suggesting...
Or UV?
Yeah, I would suggest integration by parts for the silly reason. I'm integrating. Can't do it that well off the top of my head, but I certainly can differentiate it. When I'm trying to integrate and it's really easy to differentiate something, I suggest that maybe integration by parts is the appropriate way to go. And, actually I can do it in my head, it works quite nicely. Over here, I'm going to commit to maybe a W being equal to, I don't know, you guys let me play for a minute. Does this make you happy? Why not?
Same thing.
Yeah, I think it's begging the question. I think the question is, can we anti-differentiate inverse cosine? And when I split it up this way, I've got the same darn question. That just screams out to me, maybe my appropriate choice would be inverse cosine, because, like I said, I know how to differentiate it. And maybe dV be everything else. That's just d. Let's pay the consequence of our actions. I think dW is going to be nothing more than over I agree. I think that means V is going to be equal to this. Now, I think integration by parts formula is going to do me a lot of good if I can rewrite my one integral as an expression involving another integral that's easily integrable. But I think that second integral is going to be the product of these two things downstairs. And if you multiply these two together, put them in the integrand's position, can you guys just glance at this and tell me whether or not that's going to be a piece of cake to evaluate? Yeah, it's just going to be maybe a quick, easy substitution, isn't it? Let's finish it up. We've gone this far. This leaves with 2 times the product of my U and V minus twice the product of these two. And so diving in, maybe committing to
U squared. You can use U squared as your substitution.
Yeah, or how about going further?
1
what
minus
about
U
letting
squared.
Z be the entire radical? That being the case, the derivative is already upstairs. Well, neglecting a coefficient of -1. Tell me if I'm skipping too much. That means I'm anti-differentiating 1 over root Z. That means I'm anti-differentiating Z to the -1/2. So raised in the exponent divided by the new exponent, would that give me a -2? You guys be honest. Whoops. It's okay. Or did I skip too much?
What does that bottom line say to part cosine?
So 2U inverse cosine of U.
Oh, okay.
What's next?
Back substitute.
Yeah, I think I merely need to back substitute. And in back substituting, I forget an action. What the heck was
Root
it?
X.
Oh, it's root X. Got it. So 2 root X inverse cosine of root X minus 2 times 1 minus X. Oh, you guys, we don't need tables for that, do we?
So couldn't we have just done like 1
Yeah.
root X times the inverse cosine of root X?
Absolutely. Or you know what you also could have done, Sean? You could have just immediately dove into integration by parts.
That's what I mean.
You don't have to dive into the U substitution first. I did it because somebody suggested he did it. And I do think at a glance it is an appropriate use of it because it's so fancy.
If you end up back substituting to get the negative.
Yeah, that's true. That's a downside. Anybody else in this one before I leave it? Yes.
So when we have square root of x, our options are to either replace it with the u or square both sides?
Yeah, I could just as easily have done it the other way. And sir, a lot of times, I don't relate du to dx prior to squaring only because it makes things look more complex. I just think in this example it was appropriate not to square both sides prior to differentiating, only because I saw this derivative neglecting that numerical coefficient as a factor in the integrand's position. That's the only reason why I did not commit to squaring both sides of this equation, or shall I say in English, that's why I did not commit to a rationalizing substitution. Anybody else want to shake me up on this? All right. I'm putting some of you to sleep, I'm sorry. Jeepers. And you said, Brad, 23?
Yeah, I just didn't get the right answer.
You
Or
know
I
what,
didn't.
it's too good for me to pass up. Can we look
Yeah.
at it? Because I think you said one or the other, but I'll take a peek at it.
Yeah, the book got a different answer. I did. I did it right.
There is,
So
is it like, the word is gonna be, you know, like we have to continually square or choosing variables before they can be found in table. What is a table like?
Oh, I apologize. I see your question. He's saying this. If you go to the back of your book, got a lot of tables of integrals, actually not that many, but some. And he's saying, do you recognize one that matches the type of problem you have? Maybe not yet. So first complete the square or make a u sub, something to clean up a little bit so that you can recognize one of these integrals somewhere in the back which you can use. I don't care about that. I want you to be able to vacuum the next period. So can I take it with my approach? And I've lost it. X squared minus 6x. Did you guys agree that in this example, it does seem like I probably should be able to commit to some kind of trigonometric substitution?
yeah.
It's just that I don't like committing to trig subs without the difference or sum of two squareds. Because that's when I'm able to evoke one of my Pythagorean identities and rewrite what's in integrand's position as a single term expression. I said integrand's position, I meant Radicand's
So
position.
all I did here was just pulled out a root x and
Did you really?
yeah, and then I did
My apologies, I didn't even think of that.
partial fraction decomposition.
Got it. So with partial fraction decomposition. What's next?
Multiply both sides by the
Say it
stuff.
again.
Multiply both sides of the stuff.
Don't know if that'll be my next step, sir.
Is it supposed to be bx plus c? Because
Oh, my apologies.
Well, that was a question, not a.
And my answer is, it doesn't matter. I think either one of them's wrong. I think it's wrong because I can't commit to partial fraction decomposition without first having a proper rational expression, and it's not rational. And since it's not rational, it involves its roots, I can't go in this direction, either of those two directions. I think I'm 100% out of luck. Do you guys agree? And if you agree, do you like what I said? Did you like what I said earlier when I said, "Oh, looks like a sum of difference two squares"?
Yeah.
And I think I can force the issue. Because I think I can add my funky looking form of 0 in the radicand's position, namely 9 plus negative 9. Give me downstairs the square root of an x minus 3 quantity squared. Plus, hold it, I meant minus 9. Do you guys agree? Ooh, we're home free. Let's dive in. X minus 3 is going to be interpreted as, you tell me.
John.
I can't hear you. So 3 secant theta?
Oh.
So that dx is nice. But I think that's going to give me downstairs anyway. I have no clue. Hold on, you guys. Downstairs, isn't that going to give me a 3 tangent of theta? But I think my dx is going to give me my 3 secant tangent. Or shall I say, that's merely going to give me a 1 secant theta? Or shall I say, did I miss something?
No, I was just saying it's pretty.
It is beautiful, isn't it?
Natural log.
this is where the book lost me, because I did it this way too, and I got x minus 3 plus root x minus 3 squared minus 9 over 3.
Say
And-
yours again. Root.
X minus 3 plus root x minus 3 squared minus 9 all over 3. See how I set up my little triangle there?
Oh, I see.
Is that right? I mean,
Oh, yeah, I agree with that.
so
I
the,
read too many radicals.
the book did it without the 3 in the denominator.
They do that on a lot of problems, and I don't know if it's a property of natural
Are you saying this is
laws
not what you have?
No, I had that all over 3.
all over 30.
It's okay. I don't think yours looks very nice. I like this one a lot better.
How did you get rid of the 3 in the
Oh, it's a
denominator?
piece of cake. Let's do it your way.
Okay.
Oh,
You see it already. Just math deep. Call it what it is, just another constant.
It did this on so many problems. I'm sitting there scratching my head.
But you have to confess, Brad, that this is so much nicer.
Yeah, it does.
Why would you want to be redundant?
Yeah.
Yes. Plus,
root x plus 6.
that's what the book has?
No. Book has what you have. Above that.
So double check that. Look at the back of your book and see what it says. Because he's saying the back of the book has what I have. He's saying the back of the book has this. And I agree with that. But
Sometimes
that's definitely different.
sometimes these books' answers don't match up either. So.
Yeah, I don't see how I can fit that one. By the way, you know what? I should say something to you guys. Personally, I would have rewritten this differently. I would have rewritten this myself as the natural log of the absolute value of x minus 3 plus the square root of x squared minus 6. That's only because that's the way the question was posed originally. Not that it's a big deal. It's not that important. I just rewrote my eradicate. You guys, it's okay if we're not done. I mean, I don't mind taking a break today, but can we first take our break?